Hello, Geometry. Welcome to Chapter 5, Angles and Triangles and lots of things with three-sided shapes in this chapter. So we're going to start right in, and this first lesson should be, I think, a lot of review for you, naming triangles, dealing with the angles of the triangles, and some information just that you kind of cover in a junior high sometimes, but we'll see how it goes for us here, and I'll try to move right along for you. Okay, so the main question, how are angle measures of a triangle related? So you can use a lot of online things to draw triangles and measure their angles, including the Desmos Geometry and some other tools. GeoGebra. GeoGebra is kind of like geometry and algebra. GeoGebra is another tool that's pretty useful, may use in class from time to time. What I want to look at first on here is when you have these, and of course these are referred to as your interior angles. And there's three of them. 1, 2, 3. Those are going to be interior angles. When you turn the page from 123 to 124, you see this diagram here. This right here, we'll call this angle 4. This is an exterior angle. And we'll write that down later. If you extend one side, if you draw one side of the triangle out further, there's going to be an exterior angle. Okay, there's not two of them. So here at this angle, if I extend one side out, I have another exterior angle right here. That'd be angle 5. And then if I extend this side out, I have an exterior angle right here. That's angle 6. Okay, and there's going to be some theorems and properties that we have with that as well. So interior angles are the inside, exterior angles are formed by extending one side of the triangle. Okay. So interior angles, those of course, there we go. They're going to be inside the triangle, formed by two of the given sides. Formed by two of the given sides. Exterior angles, formed by extending one side of the triangle. One side of the triangle. Okay, and corollary to a theorem, that gets into some of the technical stuff. A corollary is just an add-on to a theorem. So we have a lot of theorems that we had on there already, and a corollary just kind of adds on to something that we already know. It's a statement that can be proven easily by a theorem. It's kind of the official definition there. Statement easily proven by a theorem. Sometimes I just think of it as kind of the common sense approach. Okay. So here are your names of triangles that you should be familiar with already. A scalene has no congruent sides, so if you don't see the congruent marks on there, you know it's going to be scalene. Isosceles has at least two congruent sides, at least. Equilateral has exactly 3 congruent sides. So is an equilateral triangle an isosceles triangle? Does it have at least 2 congruent sides? And yes, it does. It actually has all 3. So you could draw an equilateral triangle for an isosceles triangle, but not an isosceles triangle for an equilateral triangle. Okay, so that's classifying the triangles by sides. If you classify by angles, acute angles, you have 3 of them. Acute angles are from 0 is less than x, which is less than 90. Okay, so acute angles go from 0 to 90. Right angles, of course, have to be exactly 90 degrees. Obtuse angles go from 90 to 180. Okay, 90 to 180. And equiangular, that's 3 congruent angles, those are all each going to be 60 degrees. The other things with the right triangle is one angle is 90 degrees. And remember, the other 2 angles are complementary. The other two angles are complementary. Okay. So when they say classify, you're going to have some questions that say classify a triangle by its side and by its angles. You could have it something like a right scalene triangle. A right scalene triangle. That could be something has a right angle, but all three sides are different lengths. You could say you want an acute isosceles triangle. So you can say acute isosceles. So that means you just need three acute angles, two congruent sides, and you could say this one is 20 degrees, and that makes both of these 80 degrees. So all three of them would be acute. All three of them would be smaller. Okay, so classifying triangles by angles and sides, you put an angle word followed by a side word there. Okay, so that's what you get here. It says classify the triangle by its sides and by measuring its angles. So our protractor, we're going to use here, classify the triangle by its sides. So we're going to measure some of these angles. You know what? This one looks acute. This one looks acute. This one looks obtuse. Just to review, we can check that. Put the crosshairs right on there. One side has to go along there, and then we're going to measure this side. Looks like it goes right up to the, if I put it the right way, let me read the numbers, right up to 110 degrees. Okay, make sure you're reading the right numbers. Okay, start on this side. So here's your baseline. Find the 0, and then follow the 0 up. Okay, this starts at 180. I'm not going to follow the 180 down. I'm going to start at 0, follow the 0 up. That's 110 degrees. So we know that's obtuse. We don't have any markings on here, so we're going to assume they are three different sides. So we have an obtuse scalene triangle. So we have an angle, a side, and then a triangle word. Okay, here, this one looks 90. Let's check that. So I'm going to put my crosshairs right at the vertex. The base is here. Find 0, go up, and it looks to be 90. So this is a 90-degree angle. Three different side lengths. So we have a right scalene triangle. Right scalene triangle. Okay, I have two congruent sides here, so I know I have some sort of isosceles triangle. It looks like all of these are acute, and you can confirm that. Yep, that's less than 90. That's less than 90, and the top one's going to be less than 90. So we have acute isosceles triangle. Okay, on the coordinate plane, classify triangle ABC by its sides, then determine whether it is a right triangle. So on graph paper, you would put your symbols on here. Let's use blue. So A is at 6, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. There's A. B is at 9, 3. So that's 6, 7, 8, 9, 1, 2, 3. And C is at 2, 2. Okay, so this question up here, does that look 90 degrees? We can do a lot of math with this, but remember, if this is 90 degrees, this is going to be perpendicular. So if the measure of angle A is 90, then the slope of AB and the slope of AC are opposites and reciprocals. The word we'd use there is that they are perpendicular. So if that is a 90-degree angle, these two lines would be perpendicular. So when I look at AB, slope of AB, so that slope, it goes down 3 and over 3. So that's down 3, and that's negative 3, over 3, over 3, negative 3 over 3 is negative 1. When I look at the slope of AC, again, you can use the slope formula if you want. M equals y2 minus y1 over x2 minus x1. You have the ordered pairs, you can use that. Okay, the slope of AC. Now this is going to be a positive slope, so that's good. One negative, one positive, so they do have opposites. My rise is 1, 2, 3, 4. My run is 1, 2, 3, 4. So my rise over my run is 4 over 4, that is 1. This one, my rise was negative 3, my run was positive 3, that's negative 1. They are opposite reciprocals, so indeed they are perpendicular. They are perpendicular. So we have a right triangle, and we've proven it by showing that the slopes are opposite reciprocals, and this is going to be scalene because none of these are the same length. Okay, the rise and run would have to be the same for a line in order for the lengths to be the same. Okay, so classify triangle ABC by its sides. We're going to say it's scalene. We know none of the lengths. You could use a distance formula to prove that. Use the distance formula, and it is a right triangle. So scalene, right triangle. Okay, question 5, page 127. Find the measure of the exterior angle. Find the measure of the exterior angle. And we... Oh, I missed that. So before we get on to that, let's go back to page 126. The triangle sum theorem. The sum of the measures of the interior angles is 180. Remember that. So here you have a right triangle. So if you're looking for x, you could say, okay, those two angles are 90 plus 32 plus x. The sum of the interior ones have to equal 180. So we're going to minus the 122 from both sides, cancels both those out, and you get x equals 58. X equals 58 degrees. This one here, you have two congruent angles. Remember, they both have the same mark. So that's two congruent angles. So if this is x and this is x, I would say 2x plus 40 equals 180. Okay, the three angles equal 180, so minus the 40, 2x equals 140, so divide by 2, you get x equals 70 degrees. Exterior angle theorem, this one might be a little new. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Non-adjacent means not beside it. So when you look at the diagram at the right, this is the exterior angle. These two right here are the non-adjacent angles. Those are the two non-adjacent angles. So these two added together have to equal this one. And that makes sense because this exterior and the one it's next to have to equal 180. They're a linear pair. The one on the inside and these two all together have to equal 180. So those two should equal the outside. There's your proof. So if we're looking for the value of x here, this is my exterior angle, and it has to equal the two non-adjacent angles, the sum of them. So I'd go x minus 15 plus 110 has to equal 4x minus 1. Okay. So this angle plus this angle equals the outside angle. So simplify that. Negative 15 plus 110 is 95. So x plus 95 equals 4x minus 1. Let's minus the x over. We'll add the 1 over here. 96 equals 3x. So we get x equals 32. X would equal 32. And finally, this is the corollary to the triangle sum theorem. It's easily proven from the triangle sum theorem, the one way at the top. The acute angles of a right triangle are complementary. So if this is 90, these two have to equal 90. So if you have a right angle, you don't have to say 90 plus x plus 30 equals 180. You could just say 30 plus x equals 90. Remember, complementary are two angles that add up to 90 degrees. So then x would have to be 60. Okay, so you can do a shortened formula there. So here we have an exterior angle. These are the two non-adjacent ones. So the measure of angle 1, these are the non-adjacent, would equal 53 plus 53. So that would equal 106. Okay. Here's your exterior angle. These are your non-adjacent angles. So 40 plus 5x plus 15 has to equal 8x minus 5. 40 and 15, so 5x plus 55 equals 8x minus 5. So let's minus the 5x over and add the 5 over. I get 60 equals 3x, so x is going to equal 20. Okay? Yay, algebra. X equals 20. Question 7. In a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle and 30. Find the measure of each acute angle in the right triangle. So when I hear these acute angles, I'm thinking we're dealing something with complementary angles. So in a right triangle, I'm going to draw a picture. Doesn't have to be perfect. The measure of one acute angle, because both of these will be acute, you can't have an obtuse right triangle. It's not possible. Because this is 90, you can't have one of these angles be greater than 90, and the three of them add up to it. Now, ask me how I can show you how a triangle can have more than 180 degrees. Okay, ask me in class when you see me. But for right now, in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle in 30. Twice the sum, which means we need to do the sum first. Okay, so if this is x, this is going to be twice the sum of this and 30. So x plus 30, twice of it. So 2 times x plus 30. Find the measure of each acute angle in the right triangle. So these are complementary. So x, the first one, plus 2 times x plus 30 has to equal 90 because they're complementary angles. So distribute the 2. X plus 2x plus 60 equals 90. 3x equals minus the 60, so 3x equals 30. So divide by 3, x equals 10. X equals 10. So find the measure of each acute angle. We have 10 degrees. And we have 2 times 10 plus 30. That's 2 times 40. That would be 80 degrees. So 10 degrees and 80 degrees. Okay, that wraps it up for our examples in 5.1. You're going to have some questions at the end of the assignment that kind of put some of this all together in certain questions. So please let me know what you have issues with, and we'll keep working on it together tomorrow. So good work. I'll see you in class.